So let's take a look at the back side. This is page 4. 37 and 38, they're pretty identical. It's just that one's narrow and one's wider. One's opening up, one's opening down. I'm just going to go with number 38. Let's go with 37. Why not? 37. You guys could do 38. So first, identify your HK value. Again, H, think opposite. K, take it for what it is. So your most important point is positive 1, negative 1. So positive 1 on the X, negative 1 on the Y. Let's put a dot right there. Now, remember, if it were a parabola, you'd be using the modified pattern of 1, 1, 2, 4, 3, 9, and you have to modify it with that A value of 2, but it's not a parabola, it's a V-like graph because it's an absolute value function, which means that that A value of 2, it's kind of like your slope, and it is positive, so you will be rising 2, running 1. Let's put a dot right there. Rise 2, run 1, rise 2, run 1, all the way off the graph. And also in the other direction, or you could mirror them over to the other side if you drawed your axis of symmetry. Right? If you wanted to, you could draw like an axis of symmetry right through it, or just mirror it. Or you could just go with the pattern, but in the other direction. Anyway, is this graph going to be solid, or is it going to be dotted? Dotted, because there's no solid line underneath the inequality. So we're going to do a dotted. And we also, because it's an inequality, we need a shade. We're either going to shade in one side or the other side. Now, if it were a line, it'd be one side or the other side. But right here, it's like a V. So it's either going to shade in the inside of the V or the outside of the V. And the way to do that is to test a point. And you could test any point you want. So you could test the point 0, 0. And I actually did that, and I made a mistake. Or you could pick any other point you want. What X value would be nice to test if this is a -1 in here? It would be nice if this X were 1, right? So you could strategically pick a point like 1, -3 if you wanted to. Check it out. I'm going to pick 1, -3, and let's see if it works. So when I plug in the X value of 1 right there and the Y value of -3 right there, what will it say? Well, it'll say, hold on a sec. So as you can see, I took this coordinate of 1, -3, and I plugged in the 1 for the X right there, which is now right here, and the 3 for the Y, which is, or -3 right there for the Y. So I strategically picked this coordinate, which is clearly on the outside of the V. If it works, I need to shade in everything out here. If it doesn't work, if it gives me a false statement, I need to shade everything in here. So when I test this out, 1 take away 1, 0. 2 times 0 is 0. Bring down the -1. 0 take away 1 is -1. And over here we have this, which is -3 is less than that -1. So the question is that a true statement or a false statement? Is -3 less than -1? Yes, it is. So this guy right here does work. So it is an answer. So that means that all of these out here are answers. So you'd have to shade in everything that's on the outside of the V. Now, if I would have tested this point and it would not have worked, then I would have had to have shaded everything on the inside of the V. Okay. If you're confused about me testing the point 1, -3, you could have tested the point 0, 0. That's clearly on the outside as well, and it would have worked also, okay, because all the answers are on the outside. So you could have tested the point 0, 0. So look, if I put a blue dot right there, put 0, 0. If I were to test it, let me just show you. Plugging in a 0 right here. 0 minus 1 is -1. The absolute value of -1 is 1. 1 times 2 is 2. 2 take away 1 is 1. So on the whole right side, you have a 1. Plug a 0 over here. It'll say 0 is less than 1. That's a true statement. So this point does work. That means that all the answers are out here. If it wouldn't have worked, you'd shade in everything on the inside. Okay, so you guys could try number 38. Let's jump to solving systems of inequalities by graphing. So there's 3 of them. Which one do you guys want to see? 39, 40, or 41? Pick one. 41. 41. All right. So 41. You want to make sure that you could graph them. If you have different colored pens, that'd be good. So in order for me to graph this top equation, which I'm going to use a red pen with, I'm going to rewrite it by subtracting x and subtracting x, and I'm going to rewrite it over here. It's going to be y is less than negative x plus 2. I subtracted x from both sides to get y by itself. Now it's in y equals mx plus b form. So let's put the b value of 2 right here. And from that point, my slope is negative 1 over 1. So go down 1 over 1. Always run to the right. Down 1 over 1, down 1 over 1. And of course, you could use that pattern but backwards to extend it all the way to the other side. Now this will be a dotted line because it does not have a solid line underneath the inequality. So let's put dots between the dots. And we either need to shade in one side of this red dotted line or the other side of this red dotted line, either down here below or up here above. You could test a point like 0, 0. If you tested 0 for x and 0 for y, it would say 0 plus 0 is 0, and 0 is definitely less than 2. So that's definitely a true statement, which means that it is an answer. That means that all your answers are down here on this side. Or you could have done the shortcut. If y is by itself and this says less than would mean you shade in below. So let's shade below, but do it very lightly. So what I want to do is highlight in red just lightly right here. Okay. So now ignore it and graph the other one in blue. But we need to get y by itself. So we're going to divide by negative 2. We're going to divide by negative 2, divide by negative 2. We will have y. You have to flip the inequality symbol because you divided by a negative. And you really have a negative 1 divided by a negative 2. A negative divided by a negative is a positive, but it's still going to be a fraction 1/2 with an x on the side. And 4 divided by negative 2 is negative 2. So there's the y equals mx plus b inequality. To graph it easily, it crosses at negative 2. Put a dot at negative 2. From that point, you're going to rise 1, run 2. Rise 1, run 2. And use that pattern backwards. And this one will be a solid line because it has a solid line underneath the inequality. So let's draw a solid line right there. Now we either need to shade in above this blue solid line or below this blue solid line. The shortcut says less than, which means that you're going to shade in below. So what you really want to represent is the overlap piece. First of all, let me shade in below with the blue highlighter. So below would be over here. But the overlap piece is specifically just this area down here. Don't go in here though, that's only blue. It's down here where you have the blue and red only. So you guys should be able to do questions 39 and 40 once you've already seen 41. Keep in mind, guys, that when you have y equals a number or y inequality in a number, it's going to be a horizontal line left to right. When you have x, an inequality on a number, it's going to be a vertical line up and down. Okay, just keep that in mind when you do the previous two questions. Now the last one is a system of equations, a 3x3. And you know, I haven't been doing this with you guys, but I would like you to maybe start doing this. It might help some of you if you named your coordinates 1, 2, and 3. Okay, so if you named your coordinates 1, 2, 3. That way, when you're making a change or you're doing something, you could actually write some notes down easily. So what would you guys say is easiest to cancel? X's, 3, 2, 4, Y's, 5, 3, 7, or Z's, 1, 5, 3. I would go with Z's because I could easily change this one to a negative 5 and I could change this one to a negative 3 easily, right? So let's go with Z's. Let's cancel out Z's. So what would you do to cancel out Z's? So you could take the first equation and multiply it by what? Multiply it by 3. You put parentheses 3 and multiply it by 3. That way you would get 9x plus 15y minus 3z equals 36. Okay, and which one would I combine it with? With the third one. Okay, so you would take the third one and just rewrite it up here, which would be right there. And then finally, we're going to combine these lines and eliminate the z's. So when I go 9 plus 4, that's 13, talking about x's. 15 plus 7, that's 22, talking about y's. And 36 plus 38 is 74, correct? And this is our new equation number 1, so everybody should box that in, new equation 1. Let's label it. Okay, so step 1 is to get something to eliminate, creating a new equation number 1. Step 2 is to go back and use the equation you have not used. Which one have we not used? We have not used number 2. So let me just rewrite it. Now from that, I know I need to use number 2. I need the same variable to cancel, which we canceled z's, so I need this 5z to disappear. Which one am I going to use to get that 5z to disappear? The first one, right? Okay, so what am I going to do to number 1? Multiply it by 5. So I want to put the number 1 and I want to put times 5, and then I want to put a little arrow over here to show what I get. So this right here is like notes to myself. I take equation 1, multiply it by 5, this is what I get. So when you write little notes to yourself like this, it'll be less likely that you'll make a mistake. And if for some reason you get confused, you could go back and retrace your steps easily. So equation 1 times 5 is going to be 15x. Equation, the 5y times 5 is going to be 25y. That's positive. And then negative z times 5 is negative 5z. And at the very end, 12 times 5 is 60. So we did that to be able to eliminate the same variable z's. And negative 2 plus 15, that's 13x. Negative 3 plus 25y, that's plus 22y. Equals 14 plus 60, which is 74. Okay, so this is new equation number 2. And this is barely step 2. Step 3 is to take your new equation number 1 and your new equation number 2 and create a new 2x2 system that you need to solve. However, look at it. It's 13x plus 22y equals 74. 13x plus 22y equals 74. It's the same exact equation. So right there you could just stop, because if you know you're dealing with the same exact equation, you could even visualize it. If you were to graph it, it's going to be the same exact line. How many coordinates would they have in common? Infinite. So you could just stop right there on step 3. You don't even have to do the new 2x2 system. You could say infinitely many solutions. So please make sure you finish this page, please.